Have you ever wondered what actually gives you the energy to dance to your favorite soundtracks?
3, 2, 1, go!
Or how your phone magically lights up when it gets plugged in? Or even how your wireless earbuds get charged up?
Nice.
Well, in this video, I'm going to explain how energy, work, and power all work together and how you can actually understand how things get going in our universe. So, let's go. Now let's start with energy. So energy is like the capacity or potential to do things. It's what fuels movement and change. So without energy, nothing in this world would happen. So there are many different forms of energy that it can take. So chemical energy in the food you eat, electrical energy powering your devices, and even potential energy stored up in a ball up high. So the basic energy formula to know is energy equals mass times acceleration times distance. In other words, energy is mad. But where does energy come from? Can it be destroyed or created, or can it be transferred? Well, that's just the basic law of the conservation of energy. It says that energy can neither be destroyed nor created, but only be transferred to different ways or transformed in different forms that it can be found in. For example, take a spring. When a spring is just there, it has potential energy. Now, it doesn't sound what it is. It's like potential energy means that it has a potential to have energy. No, it's that it has a potential to be transferred into another type of energy, which is kinetic energy, the energy to move. But keep in mind that the spring is definitely not seasonal. Yes, I came up with that pun myself. Or what about light bulb? It's just having a lot of light. But where the light come from is electrical energy. But then some energy is wasted as heat. So potential energy transforms into electrical energy, and then that energy is then produced as light. But then heat is also wasted. Which is why it's kind of hot in this room right now. I have like 10 lights on. So the more mass something has, the greater the forces exerted on it, and how further it travels, it has more kinetic energy. Now let's talk about work. No. It's not the stuff you have to do in school. It's in science when work is when a force acts upon an object and makes it move. So according to Newton's first law, an object says that it will mean to be at rest or in motion unless an external force acts upon it. So then that means work. So pushing a box across a floor or lifting something takes work. So the work formula is work equals force times distance. So we're going to take a book, for instance. Let's take this as a system. So let's have a force acting upon it of, let's say, 9.8 Newton meters per second above the right here. So if I hold this above the surface of the earth about 1 meter, then we drop it. That has a work done of 9.8 Newton meters. But why is it 9.8 Newton meters? Because the distance was 1 meter, and also we have the force acted upon it, which was gravity, which then means that we multiply those two, 9.8 times 1, we get 9.8 Newton meters. So if you move a force over a longer distance, that will equal more work. So pushing that heavy box all across the floor to the room, to your friend over there, takes much more work than tossing a tennis ball to your other friend. Finally, the thing that I really was waiting to edit in this video, power. So when you ask me, what does power mean to you, Joe? Well, it means this. Yes, 670 horsepower, 626 Newton meters of torque. That's a lot of power right there, my friend. Anyway, so power just measures how quickly work gets done or how energy gets transferred. And it's all about speed. So basically the formula is power equals work over time. For example, your phone charger converts electrical energy to charge the battery quickly, so then it has high power. So compared to drip charging a phone all day like in 2014, the charger has much higher power since it does the same work in a fraction of time. So we have what we call watts, electrical power. So a typical charger could have 20 to 65 watts, unlike some countries that have 200 watts. But what's the SI unit for both work and energy? Well, it's the joule, or capital J. Well, watt is capital W. So the more power you have, the less time things get done. So in your daily life, remember that energy gives the capacity to do things and to change things. Work applies to energy and also to move things, and they both have the same SI unit, which is the joule. And power is about how quickly that energy gets used, and it is the watt. The what? For what, senor? Aha, you waited for that for over 5 minutes, I can tell. So next time you see a rocket being launched into space, you see a plane taking off, the sprint you use to catch that bus, or even you writing and watching this video at the same time, think about work, energy, and power, and how these three play a magnificent role. So now you know. Thank you for watching. Like and subscribe for more facts that you never knew about.